Hello everyone, I'm Alfian and today we are going to solve the Hackerrank challenge on the problem solving section called the picking numbers. And for this particular challenge, given an array of integers, find the longest subarray where the absolute difference between any two elements is less than or equal to 1. And for this example of the A array, we have 1, 1, 2, 2, 4, 4 and 5, 5, 5. And there are two subarrays meeting the criterion, which is 1, 1 and 2, 2 and 4, 4, 5, 5, 5. The maximum length of subarray has 5 elements. Why is it 5 elements? It's because the one right here consisting of 4 and 5 has the 5 elements, better than 1 and 2 only has 4. And for this function description, complete the picking numbers function in the editor below. Picking numbers has the following parameters: in of a of the index of n, an array of integers, and the return is in a form of integer, which is the length of the longest subarray that meets the criterion. And for the input format, the first line contains the single integer n and the size of the array is a, and the second line contains the n separated integers, each and a of the index of I. And let me explain about the function itself. Since we are using the TypeScript language, if you want to use another language other than TypeScript, you can go ahead, but for this particular challenge I'm going to use TypeScript. And the function says picking numbers, and we should write our code right here, and it takes a array parameter called the a right here in a form of number array, and the expected output of the function is in a form of number or integer. And for this sample input 0, we have 4, 6, 5, 3, 3 and 1. And for this sample output 0 is 3. Why is it 3? Is because if we look over here, we have 4, 3 and 3, and since 4 is the neighboring number of 3 and 3 is also the same, and so therefore we got the answer of 3. And if you want to look closely, we have 4, 5 and 6, but we only need one neighbor to pair them and return the occurrences of the numbers itself. Let's say 4 only get pairs either with 3 or with 5, and 5 only pairs with either 6 or 4, not both of them. And of course we choose the following multiset of integers from the array, which is 4, 3 and 3, and like I said earlier, each pair in the multiset has an absolute difference of at least at most 1, is because of the neighboring condition. And for the same number is counted as being itself, and so we print the number of chosen integers, which is 3, as our answer. So without further ado, let's solve this by writing the code. I had an approach that is considered a naive approach by using the one right here, by using the single pass iterating through the numbers of array right here, array of numbers, I'm sorry. So we starting from 1, 1, and then as we go through, we counting 2 and 2, and then the counter goes up to 4. And then when it's already 4, which is not neighboring number other than 1, then we stop the counter and starting again from 1, and starting the starting point as the number 4, and then we should recognize is the 5 is as the difference of 4, which it is. Then we of course we counting 2 and then 3, 4 and 5. But one caveat that if we happen to have like 1, 1 and then 2, 2 and then 3, 3, 3. Let's say if we iterate from 1 again and we counting to 1, and we define our neighborhood as 1, which takes either 2 or 0. Then for the next one, which is 1, still the difference is still 0 and 1. And for the next one, we counting to 3 and then 4, and then it will stop and we starting again from 3, and the counter starting from 1, and then 2, and then 3, and we from the single pass right here we are no longer recognizing 2 as our answer right here, and the real answer should be 5 instead of just 3. So that's why the single pass approach is not viable here. So another approach is by counting the occurrences of 1, and then the occurrences of 2, and the occurrences of 5, and also the occurrences or the frequency of 5. We have 3 5s right here, we have 2 4s right here, and we have 2 2s and 2 1s. And to define that, of course, we can use the Hashmap, and we can count the neighboring based on the key, which is 1 right here, to see if we have 0 in the Hashmap from the array iteration right here, still using the single pass, and to see if we already counting 1 right here, to see if we have 0, either 0 or 2, and then counting the neighboring number or neighboring key with the amount of the ones right here. So we only have 2 right here, and we don't have 0, and of course we are counting as 4 right here. And then for the maximum number, we store that as the temporary variable. And then for the next one, we are iterating the key of 2 right here. We have 2 values or 2 occurrences of 2 right here, and let's see if we have neighboring key of either 1 or 3. Since we don't have 3, then of course we are using 1 right here, and it's still 4, and it's still the same as the one that we iterate the key value of 1 right here. And for the next one, we have the key of 4, and check if 4 has the neighboring value of neighboring key of 3 or 5. We only have 5 right here, and thus we only counting 5 including 5, and the result is 5 as the current maximum value. And for the 5, of course, we only either recognizing 4 or 6. Since we don't have 6, then we are counting 4, including them in our counter right here. So we have 5 as the result. That is the neat approach, and it's not so naive. And let's define this by using the constant called the Hashmap with the data type of map, and inside the map we have the definition of number as the key and number as the value, and we declare our new map constructor right here. And so there you have it. We have the Hashmap variable that we can insert from the array, converting into the proper Hashmap e-value pair. So in order to fill the Hashmap and address every occurrences of 1, 2, 4, and 5, of course we are using the single pass, like I mentioned earlier, using the for loop at I equals to 0 as long as I is below the A of the property of length and I plus plus. And we are iterating our A array right here from the parameter, and we are inserting the value into the Hashmap, counting them based on the key that we define by using the Hashmap.set method. And for the first parameter, we take the key. The key is of course the 1s or 2 using the A of the index of the current index. And then for the second parameter, we can fetch the previous value from the Hashmap using the get. And then the get, if you think the get right here, and we take the previous value from the A using the key right here, A of the current index. Let's say if we have key of 1, then we fetch the value from the Hashmap from the previous value, and then adding them by 1. And we have red underline right here. And for the get method, this object or this method is possibly undefined. It's either number or returning undefined. Undefined happens only if the get value or the get method we don't have the current key for the previous Hashmap fetching method. And to get around this, we can wrap the Hashmap.get method, and then since it's undefined, then we can use double pipe to use a fallback, and the fallback value is 0. Why? It's because the Hashmap.get has the possible returning value as the undefined. If you look closely of the method of the get right here, using the key of the current iteration of a array, and the after the colon right here is either we get the number or we get the undefined. And since undefined is considered a falsy value, then of course we use the double pipe operator right here, or the as the fallback value from the falsy. If we get, let's say, if we get null or undefined or 0 or just empty string, then it's considered a falsy value. Then of course we are returning 0 as the fallback value right here. So, and wrapping this inside parenthesis, then we either get a value or getting a 0 instead of just undefined, and thus it will be suitable to be added by 1 right here. In short, if we already have the value of 1 from the Hashmap, then we are going to add it by 1. But if we don't have the value beforehand, then of course we are assigning the key value pair of 1 for the first time. And to view this, of course you are curious about the Hashmap value of what's happening inside the Hashmap variable. Of course, I'm going to use the console.log using the Hashmap as the parameter, and for the since it's requesting a number, then of course we are returning our placeholder as the 0 right here, just for the console.log. And we have the console.log as the data type of map right here. We have key of 4, we have 1 occurrence of 4, and we have 6 key, we have only 1, and 5 we only have 1, 3 we have 2 of them. It's because we have the 3 key right here and the 2 right here. Using the previous fetch value from using the get method right here, and we got the previous value of 1, or the first occurrence of 3, and then it's adding by another 1, and of course we get the 2 right here as the value, and the 1 right here we only have 1. Then of course the key value pair, this is the key and this is the value, we only have 1. And for the example number 2, still the same, we only have 1 right here and also 1 right here, so we only 1 key of 1, we have 2 occurrences of 1, and we have 3 occurrences of 2 right here, and the last one we have 1 occurrences of 3. And so let's go back to our code and let's delete this console.log or comment this out. And then for the next one, like I said earlier, we need to define the current maximum value from the neighboring numbers by using the key from the Hashmap by using the let, and we define our current max value, and we define it as 0, and the return value we can pass in our current max as the return integer right here. And to iterate the Hashmap, I have 2 approaches by using the for of loop, using the constant with the destructuring variable using the key value of map, using the map right here in the Hashmap, in the Hashmap, and the type number can only be iterated through when using the down level iteration flag or with a target of ES 2015. And we have the type error right here, and of course we can wrap this inside the Array.from Hashmap right here, and that way we are converting the Hashmap key value pair into an iterable array, and we can destructure this and define the variable from the destructured value from the destructured Hashmap right here as the array. and we can see using the console.log, I'm using the template literals in the $sign, and then we define the key, and then using the colon sign, and the next one using the $sign, and then we assign the value inside the curly brackets right here. And so let's run the code to see what it is about. And we have the same thing as the Hashmap right here, and we have the key 4 with the value of 1 for right here on the F1, and we have 6, 1 6, and 1 5, 2 3, and 1 of 1, and it's the same thing. And if you look closely, you see the for loop right here, it takes another memory complexity. It's because we are converting the Hashmap and then using the restructuring the variable of the Hashmap and using the for of loop, that is taking an extra complexity of what we are trying to solve right here. So to get around this, we can use something called the Hashmap.forEach method, and it takes the key as the parameter and value as the parameter, and we can get using the console.log to see what is it about. Is it the same or is it not? Using the same template literals, using the $sign and then key, and then for the using the arrow right here, just thin arrow, and then we are assigning the value as the string right here. So let's run this again to see if the for each method or is supposed to working just like using the for of loop. And we have 1 right here. I believe it is a key, but just the position is swap. Yeah, that is the difference between using the for of loop and the for each method. And we have the value right here of 1, and the key is placed right here after the value. We have the key of 4 but placed on the right side, and the value is placed on the left side. And that is the main thing of using the for each. You should be careful of using for each so you don't get confused. And the first parameter should be the value, and the second parameter is the key itself. So let's run the code again, and this is the correct arrangement. We have 4 right here as the key and the value as 1. So that is the main thing of using the for each method, and that is the difference between using the for of loop and the for each method. So let's solve the actual code. The very first thing, we can use the let. We can get the neighboring value using the neighboring value or neighboring sum. That way we are trying to get the sum of the neighbor either by, let's say if we are iterating 2 right here, we are getting either 1 or 3, and then we are returning the maximum between the using the 2 with 1 or 2 with 3. Since we don't have 3, then of course the maximum possible value or the maximum possible elements is 1 and 2, which is 4 right here. And for this 4 right here, we are either getting the neighboring sum of either 5 or 3. Like I said earlier, since we don't have 3, then of course we are getting only 2, and since we have 5, of course we are returning 5. 1, 2, 3, 4, and 5. And then we can define that by using the Math.maximum method, and we are taking the parameters to see which one has the maximum integer from the neighboring sum. Like I mentioned earlier, we can use the key right here using the Hashmap.get, and we use the key and then +1, or Hashmap.get. I'm using the enter sign right here or new line to make this more readable, and using the double pipe right here to resemble the, or to check which one is higher or which one has the maximum. Not using the double pipe, I'm sorry, is because we are using the max method. Then of course we should use the comma to compare which one has the highest value possible, and then we can get the key -1 or key +1. And to get around the possible value of undefined from the get method, then we can of course use the wrapper right here using the double pipe sign or double pipe operator with the 0 after that. We can simply use the wrap this in a parenthesis and then using the double pipe and takes the 0, and the same thing goes to the next one right here. We are wrapping the same thing as the one above that using the 0, and that way we are either getting the, let's say we are iterating 1 and we either get the key 0 and the key of 2, and the neighboring sum of 1 is of course 2 right here, and we have 2 as the neighboring sum variable right here. 2 I mean is the counter, not the key right here. And for the next one we can get using the current maximum value is equals, we are assigning this using the Math.max again, Math.max method, and for the first one we can see if the current maximum value is the higher or not against the neighboring sum plus the current value of the key that we are trying to iterate right here. So that way we are comparing the current maximum value, which is 0 right here, to see if it's higher or not than the combined neighboring sum. Let's say if we are iterating 1 right here, we have neighboring sum of 2 plus the value of the current iteration, which is the 1 itself right here, and we have 2 right here, so the combined sum of the neighboring and the current value is 4. Since current max is 0, then of course it will be replaced by the variable right here, and the current max will return as 4. And if we happen to iterate the 4 right here, the key of 4, we have the value, we have the neighboring sum of 5 right here, which is 3, the neighboring sum of 3, and then we are comparing the current maximum value, which is 4 right here from the previous one with the 1 and 2 right here, and we are comparing this part against the 4 and 5 right here. We are comparing the current max with the neighboring sum, which is 5 right here, which is key of 5 has the occurrences of 3 with the current value of 4 right here, and we have 5. Since 5 is higher than 4, of course, then we return current max as 5. So let's run the code to see if it works. Let's submit this, and there you have it. So I hope you understand my explanation. If you still don't understand, you can ask me in the comment section, or if you have any better solutions regarding this challenge, tell us what you think in the comment section. I hope you have a great day, and I will see you in the next video. Goodbye.